Going off of our discussion of systems of inequalities a little bit ago, I want to talk about a concept called linear programming. And this concept of linear programming is basically that we have a set of constraints, linear constraints in x and y, that we want to minimize or maximize a particular quantity based on those constraints. And a lot of this is used in businesses. You can kind of simplify it and say businesses that make two different products that want to maximize their profit or minimize their cost. We're not going to put word problems to it here, but it can be used in that regard. The way that we're going to use it is basically we're going to plot the system of equations. We're going to plot the solution set, and I'll talk about where this c equals 6x plus 7y comes in later. But for now, let's graph the system of equations, system of inequalities rather. X greater than or equal to 0, there's a vertical line at x equals 0, shading all the way to the right. I'm not going to bother shading to the right because that's basically everything we see here, but that would be x greater than or equal to 0. Y greater than or equal to 0 similarly is going to be this x-axis down here. And since it's greater than or equal to 0, we would shade above the line. But again, I won't bother because that's everything we see here. We'll just keep in mind it's not going to pass those up. These other two, x plus 2y less than or equal to 16, and the other one, you can either plot using intercepts if you'd like, or you can solve for y to help with the shading. If I solve for y, I believe I would get y less than or equal to negative 1/2 x plus 8, y-intercept of 8, and a slope of negative 1/2. So let's put that together. So that would look like something like this, I believe. Looks pretty close. So something like that. You could see that it's actually going to hit at 16 right there. You could solve for that algebraic if we might need that information, we might not. And then this last one, if I solve that for y, y is less than or equal to negative 5/3 x, in this case plus 15. So if I graph that, y-intercept of 15, slope of negative 5/3. So negative 5/3 is a pretty steep slope, or at least at first. 1, 2, 3, 4, 5. And 3 would be like this. Just double check. 1, 2, 3, 4, 5, 1, 2, 3. Yep, that would be negative 5/3. So it's going to look something like this. Hits at 9 on the other side. Okay, so I've got my system of inequalities. For those other two, they're both y less than, so I'm shading below. So if you look, the region where everything's going to intersect is going to be this region right here. This is the solution set of that system of inequalities. Now, what are we going to do with this? We're going to minimize that c equals 6x plus 7y, that quantity, subject to these constraints. And the way that we do that is we find the intersection points, or the vertices of that solution set. So we can see that, okay, 0, 8, 0, 0, 9, 0, 0, 0, 0, 8, 9, 0. And there's one right here that, I can't really tell if it's supposed to lie on 6, 5 or not, but you could do a quick check. If you plug the ordered pair 6, 5 into these and kind of treat them as equations, you would see that 6, 5 is that intersection point. If you weren't sure, you could always treat these like equations and solve that system to see where they cross, but that would be 6, 5. Okay, I just didn't graph it perfectly. So I'm going to find those vertices, and what linear programming does is there's a theorem that says that the minimum or maximum value of whatever quantity we're trying to minimize or maximize will always occur at one of those vertices. Will always occur at one of those vertices. So once you find your vertices, you're going to plug those all into that green c equals 6x plus 7y. We want the minimum, so we want the smallest value of c. So let's see what that gives us. So for 0, 0, c is 6x plus 7y is equal to 0. At 0, 8, c is 6 times 0 plus 7 times 8. 56. 9, 0, c equals 6 times 9 plus 7 times 0, that's 54. And finally at 6, 5, c is equal to 6 times 6 plus 7 times 5. That's 36 plus 35, which is 71. So the minimum is going to be the smallest of these values that we found. That's this. So you could say minimum of 0 when x equals 0, and or you could say maybe more briefly at 0, 0. The maximum is the largest of those, so this would be the maximum. There's a maximum value of 71 at the point 6, 5. So depending on whether it asks for the min or the max or both, that is more or less what you're going to set up to solve that linear programming problem. You're basically just solving the system of inequalities, getting those vertices, and plugging them into this, what's called your objective quantity, and finding the min and or the maximum.